and who we are. ISC is a nonprofit public benefit corporation. That means we don't have shareholders. We do have a board of directors, but really we are a public benefit organization. We're dedicated to supporting you, the Internet community, specifically the infrastructure of the Internet, or as this slide says, the universal self-connected organizing Internet, self-organizing Internet, excuse me. And this part's really important to all of us here, the autonomy of its participants. We very much believe in the autonomy of the members of the Internet community. And the way that we support that mission is by developing and maintaining core production quality software. That includes Bind 9, Bind 10, ISC, DHCP, and after, as well as RPKI is a new project that we're developing. Excuse me. And protocols. We support and have been involved in the development and implementation of DNSSEC, IPv6, and other Internet protocols, and operations. So some of our projects that you may or may not be aware of course, everyone who's on this call is well aware of Bind. And you may already be aware that we are doing a ground-up rewrite of Bind, Bind 10, which is in its third. I'm sorry, I'm pausing for a second because I see a comment in the questions and answers that people can't hear me. I want to make sure you can hear me. So send me a chat and tell me if you can hear me. I'm not talking to air, am I? Oh, good. I see people can hear me. I'm not going to worry because it's one person. Sorry about that. Okay. So as I was saying, I was telling you that Bind 10 is a ground-up rewrite of Bind of the DNS protocols that's now just about to start its third year of development. ISC supports our software with professional services. Those include 24/7 technical support, custom development, training on our software and on Internet protocols, consulting, and we can also help with network design, audits, helping you develop best common practices. So we also offer hosting for other open source projects. That's our Hosted At program. We support protocols that I mentioned, such as IPv6 and DNSSEC. We have been very involved in developing those through the IETF. Our public benefit presence does include working a lot with the IETF. It also includes working with ICANN, ISOC, and other standards-making bodies and Internet collaborative organizations. We also have a security area where we have a product called SIE, which is a platform on which security professionals exchange and share information. And there's a webinar coming up about that in a couple of weeks. So I want to move on from the ISC advertisement to the meat of the matter. The first Bind 9.8 feature we'd like to talk about is the DNS Response Policy Zone, or DNS RPZ. And here to talk to you about that this morning is Barry Green, who is the CEO of ISC and was very involved in the development of this feature. And I am just making you the presenter, Barry, and you should be able to take it away.
Okay, thank you. So thanks, everybody. As Larissa has mentioned, and this is something new we're doing here at ISC, which is every time we come out with a new version of Bind or DHCP or any of the software we manage as managed open source, we're going to do feature updates like you get with most other products out there. So that way, when the new version comes out, you have something in addition to the READMEs and things like that and the correspondence on the mail list. And a place we can ask questions. And then if you're looking for slides and things like this, like if you're looking for any illustrations that you can sell to your management, just contact us and we can send over slides to you so you can say, this is why we need to upgrade, for example. We've all been through that before as operators, trying to convince management that now's the time to upgrade it because of a new feature. So over here on the next slide, this is just a brief illustration or a brief description of DNS RPZ, which has been in beta and has been talked about a bit. Where the genesis of this came out was looking for a more efficient and effective way to get blacklist out to help protect enterprises. Some of the techniques and approaches we were using in the past were where each query coming in, you're doing a query going out, was not fast enough with some of the applications we needed. So what we're doing here is we're taking a zone transfer technique and using it to push out to your caching resolver. So just give illustration of how this works. This is a slide I think everybody here should be familiar with, because I'm assuming everybody here is a DNS operator in some way, shape, or form, so you kind of understand the approaches here. What we're doing here on the next slide is off to the side you have some sort of security company, a university, some sort of operational security organization. Somebody out there maintains a blacklist of bad domains, domains that you say, okay, if you go to this site, you're going to get owned. Or if you go to this site, they're trying to sell you malware software or things like that. So this particular site is a spam operation or a phishing operation. So for whatever reason, it's in somebody's blacklist. The old way of doing it is, and the way it still applies, is you set up your servers to go out there and query that. In other words, every time a domain comes in, you go out there and query that server and you get a result back. With this technique, you can take your cache and resolver and you can use AXFR, IXFR transfers and move it down into the resolver. So for instance, what this provides is a push capability. So using, what we are familiar with as zone transfers, and you're able to push it down. So now when somebody connects up, it's a push sort of result with it. Give it another illustration of this. You got some domain out there that is identified, xyzbadness.com, and Spanhouse or Serval identifies it as like a drop area. Then it gets the intel. Everybody says it's a bad address. It gets added to the blacklist, and it gets pushed down. So what that means on your side from an operator perspective, people who operate these things, it makes it simpler for you because somebody is pushing and updating automatically. You can subscribe to it. Core uses that we see with this is malicious drop sites, command and control sites, walled garden notifications. There's interesting uses out there that we see right now, and there's probably going to be as people deploy and play around with the other uses that people can use with it. We already have one organization who's announced immediately when we came out with the beta, they immediately deployed infrastructure at Serval. So if you're looking for a organization to try this out with in the lab, fire up and try it out in the lab, you just contact Serval, and they provide here's the feed, and then you can start trying it out. There's also a mail list that you see in the back here that you subscribe to, and you can ask for others who are actually bringing up feeds. There's several people bringing up different feeds with it. And you can have multiple feeds, so the technology allows multiple feeds. We've pre-announced this. In other words, we went out there to the operational security communities, MOG, and other groups. Paul Vixie posted this on this blog article, Taking Back the DNS. So he talked about this. The feedback we're getting with it is pretty positive. There's some concerns that it could be abusive, but like any new tool, any new hammer we deploy in the internet, there's pros and cons to each usage of it. From the operational security perspective, we were seeing that this tool is very useful to get out there, so that's why it's out there. There's also, we see the emergence of an ecosystem, which is the ISC goal. Us as a public benefit company, one of the nice things we can do is we can actually do things to actually build ecosystems where all we do is be the instigator. We're not like, we're not building our own blacklist, for example. So here on ISC's role with this, Paul Vixie and Vern and a couple others worked on the whole specification, so we got a specification you can download. It's an IETF draft format right now. We may take the IETF, we haven't decided yet, but it's there, so you can look at the spec. And so we can improve the spec as we learn so that we have a specification for it. We get the functionality in bind, so there's a reference. So that way, any other DNS recursive software vendor can look at it and reference it, and they can code it themselves. So we can actually, perhaps get a standard way of doing this. We're working with all the different potential blacklist providers out there. Some of them are, security organizations. Some of them are security vendors, and then we're working with different operators who are playing around with deploying it. So all of it is instigating sort of stuff. ISC is not going to do our own blacklist. We're not really set up to do our own blacklist. While we have something like Security Information Exchange, we're more facilitators for security peering, not for actually developing the reputation stuff. There are others out there who are already doing it and do a really good job at it, and we just help them as our partners and allies. And then over here, there's a discussion list. You can sign up to it. There's a DNS RPC interests. So if you're really interested in this, sign up to the alias, ask questions on there. You can look at the original where Paul Vixie put a post out there. He also presented this at Black Hat. If you do a Google on taking back the DNS, you see some broader discussions with it. This draft is updated. This is an error here. I think we're on version 3 that we're getting ready to post up to it. But if you look at that directory area of FTP, the ISC/DNS RPZ, then you'll see that the draft's in there. And it's officially in bind 9.8. There was a patch that you can load up before, but now it's in 9.8 officially going forward. So let's hand it back to Larissa.
Thank you very much, Barry. So at this point, I want to introduce Michael Graff. Michael is, excuse me, our Bind 9 Engineering Manager, and has also been a Bind 9 developer for many years, since the beginning of Bind 9, I believe. So anyway, Michael, you're now the presenter. Take it away.
Hello. As Larissa mentioned, my name is Michael Graff, and I've recently become the Bind 9 Engineering Manager. And this is my first major release of Bind, and I'm pretty excited about it. I think it's actually a really good set of features, and I think it's a really good product. So the first thing I'd like to talk about is the, let me get used to WebEx, okay, is the DNS 6.4 feature. DNS 6.4 is a transition mechanism that primarily allows an ISP or a device of some type to be on a v6-only network but still reach v4 services. It actually works with a component on the ISP side, typically, that is a NAT 6.4 gateway that does the translation between IPv6 and IPv4. It looks a lot like this, typically. In this particular case, it looks much more like a home user or a business user with an IPv6-only connection to an ISP, where everything is IPv6 only at that point, but the back end still has IPv4 available. Another typical use of this would be a cell phone or some other device that there are very, very many of these devices, and addressing each one with an IPv4 address, even if you use the traditional NAT of /8, 10/8, you still run out of address spaces. A little bit of information about how it's configured is here. There's a well-known prefix that you can use for a NAT 6.4 gateway, or you can use a private one for your ISP should you want to, or your environment. In the case where a DNS 6.4 backed host is attempting, or IPv6-only host is attempting to connect to a v4-only service, the DNS 6.4 gateway kicks in, where you ask for the zone itself only contains A records, which point to the IPv4 services. So whenever you request a name, say www.isd.org, if it only had A records, DNS 6.4 will convert that into a quad A record using the prefix that you've defined, so that it can talk to your NAT 6.4 gateway. And to the v6 client, it looks exactly as if it had v6 that remote service had v6 connectivity. In the case where v6 and v4 are both available on the service, the normal operation occurs and nothing has really changed. Another new feature is the GOST DNSSEC algorithm. This is a Russian public key algorithm, and it's primarily for use in countries where RSA is either illegal or somehow regulated. It's another DNSSEC algorithm which you can use to assign zones. It's exactly like RSA SHA-1, RSA SHA-256, DSA, and other types, and most of the time just use one of the RSA variants. Don't bother with GOST until you actually have a need for it. The root is currently not signed with this algorithm, so even if you sign your zone, it's not so effective because they still have to use RSA to get there. If the root becomes signed with GOST and RSA, you might want to revisit this and start signing your zones with GOST as well to provide services to other countries where RSA might not be usable. And speaking of DNSSEC, for those of you living under a rock, the root has been signed. Well, we ship a version of the root key, and we use our built-in RFC 5011 maintenance to maintain that. So what this means is if you enable DNSSEC validation, which I'll show you how to do in a moment, pretty tricky. That if you enable DNSSEC validation, what you end up with is a zone. It uses the key that's built into bind one time to verify the key, and then after that it will track the key changes using this protocol called RSC 5011. So if the root key changes while your server is running, it will simply track the changes and you won't notice any differences. And you don't have to do anything to maintain that. It's automatically maintained inside of bind. If you turn this on an older version of bind and the root key has changed, you're going to get validation errors immediately, in which case all you have to do is update a particular file in bind to say, here's the new root key, please use this, or upgrade bind where we will have the new key. And we do believe that DNSSEC is hard enough as it is, which is why we made it so simple. To turn on validation inside of any resolver running bind 9.8, that's all you need to do. If you trust us to provide the correct root key and you trust us to provide the software that backs it, that simple operation will get you up and running with DNSSEC validation very quickly. Another feature is, this one's a little hard to explain because it has a lot of focus primarily on one application. In this case, it's Samba. But our GSS API layer, which stands for Generic Security Services API, it's a programming layer that primarily works with multiple service providers, security service providers. In this case, it's primarily Kerberos. We've made some improvements there on how to configure it so that it's very easy to use in a Samba component, or very easy to use in a situation where you have multiple realms that you support. As opposed to having to configure a lot of different steps, a lot of those are automatically configured now based upon the client request. And there's a little bit of information here about Samba. A lot of this feature was written by the people at Samba in cooperation with us, and it was a really wonderful to work with these guys. GSS API configuration is simply this now. You specify where the keys are for the Kerberos 5 key tab, and bind will select the right entry to use out of there based upon the request that comes in from a Windows client or from a Unix client if it's speaking GSS API. This is primarily done for Windows Update. Whenever a Windows machine does a dynamic update to an Active Directory host, it uses GSS API to do that. And along with that, we've made some modifications to a back-end driver. This particular We've always had this contributed driver called DLZ, which stands for Dynamically Loadable Zones. It's primarily in use for things like MSQL backends, where the zone data itself is stored in MySQL or Postgres or some other backend, and bind will query that every time it gets a request and then cache that response for a short while. This is for use in hosting companies where you have a lot of domains you might want to host, but you really don't want to have a zone file for each one, for example. The performance of this is not stellar, but it does work in many cases, and where it does work, it works very well. The problem with these is you had to compile them in. With bind 9.8, and I do say bind 9.8 here, but I actually am going to be meaning bind 9.8.1 because it turns out we didn't turn this on in 9.8.0. The DL open driver will be compiled in by default. This means that if you get something from your ISP that is 9.8.1 or later, you don't have to do anything special to load one of these drivers to support Samba or other types of systems. You don't have to worry about having to recompile bind to add a feature to it in this case. And this is a big change for us because most of the time you have to recompile bind to enable certain features. This one allows you to load dynamic drivers on the fly for the DLZ backend. The first one is really an LDAP driver, and this is written by Samba. Once again, they are the provider of this particular driver within the Samba 4 release, which is still alpha and beta at best. But whenever it does go live, we're going to be ready to become the Active Directory component within this environment. It's not yet trivial to configure, so it's not a mainstream release, but it's something kind of showing the direction we're going with more dynamically loadable drivers and such. A feature that you might want to start using if you actually use stub zones is an improved type of stub zone. And what I mean by this is the type stub zones really don't always behave as people expect. Sometimes they do, but most of the time they're not quite what people are looking for. So we've added a new type of static stub which behaves more closely to what people tell us that they want whenever they get that, whenever they request this type of behavior. we didn't just change the way stubs work because we didn't want anybody who's relying upon the old style behavior to suddenly have to change configuration files. So static stub is unfortunately the name we've chosen. It's not the greatest name, but it does describe it pretty well. The old type stub, if you put this in your zone file or in your named.conf file, what it does internally is the bind9 resolver will run out, query for NS records from one of those hosts, and cache the answer. Okay, that makes sense. However, if those NS records then point back to these servers, all is good. But if they point back to the public servers, for example, if you're mirroring a zone and a local copy of, say, a lot of times this was used before RPZ was around, where you would mirror a copy of some remote database type zone, but the NS hosts are still pointing to the remote server, so you start talking to that one and never talk to these again until the NS records need refreshing. It's not really the behavior most people are wanting. Worse, if somebody queries this bind9 resolver, they actually get back these modified NS records if you do modify them. Once again, not really what people are wanting. So a static stub zone behaves much more like what people are asking for, which is you send a request to bind9 for something inside the zone. It redirects all queries for that zone to this set of servers and then caches the answer normally. The big difference here is that if those NS records then point off into some other set of servers, bind will continue to use the ones defined in its configuration file and will not use those NS records for resolving that zone. However, it will return those records that it gets back from these servers to the client. So bind can use a different set of servers to resolve example.com in this case than what is listed as NS hosts. And that's the behavior that most people are looking for when they're looking for a static stub zone. So kind of to recap, once again, it really just the old type of stub really just ensures that NS records remain in cache, and it will return these to the clients, which is sort of a pollution problem in some cases. It does allow adding a private or non-delegated domain into a resolver. It also allows you to override existing domains. If you decide that there is a malware site, you can add a stub zone pointing off to a server that serves a good copy of this zone, for example. Although the RPZ feature is probably what you want to do that with that now. It's far less maintenance. The static stub allows the same features, but it behaves slightly differently, where it actually just redirects all queries, as described before. So when you want to use one type over the other, well, static stub is really just a shortcut to normal DNS search, and it's kind of like a specialized forwarder. You want to use static stub when you want all queries to go to a set of servers, but you do not want this redirection to be exposed to clients. And our primary customer for this was a DNSSEC testbed. In this case, they have two completely different sets of customers, where some are involved in a testbed, which is the top example here, but they still have to provide service to normal customers who are not part of the testbed, and they don't want them to see DNSSEC records. They want to very carefully test DNSSEC with a few cooperating ISPs and such. In this case, this is the environment they had. In the old stub zone case, if something were to query the top server unexpectedly, it would get back well, in order to do this, they would have to modify the NS records using our existing stub zones. So our old stub zones wouldn't work this way unless they modified the zone data before they signed it, and they didn't want to do that. They wanted the NS records to point back to the public site, but they wanted queries to go to the special set. In this particular case, this is the behavior that they wanted, which is that if a client reaches one of these validating servers but isn't part of the testbed, it just reaches it based upon configuration or something unexpected at the ISP. Most ISPs aren't even aware, in some cases, who's querying their validating resolvers, so this is probably a very common case. If it gets back those NS records, it will continue to use the public records and not be part of the testbed. In the old stub zone case, it would actually become part of the testbed just by using this as a stub resolver, which isn't really what people were wanting to do. So it doesn't leak the NS data if it's been changed, for example, and it also works properly. Another feature that is a little strange to describe because it was originally written for the Samba project, but it turns out we're not even using it, but we left it in case other people find it useful, is something I'm calling dynamic ACLs. In this case, for updates only, dynamic updates only, bind can call out to an external process to say, should I allow this update or not? This allows a lot of changes in authentication mechanisms, in policies that you can't necessarily describe using a bind9 configuration file. You can perform out-of-band authentications, for example. You might have to query this particular magic name, and then after that you can update something. There's a lot of flexibility in this here. And we have a sample configuration and an example program that does this inside of our contrib directory if people want to look into this a little bit more. One of the major changes we've made for reliability is a client query timeout. And this is more of a modernization of bind. Whenever we started working with bind, the default timeout was set to 30 seconds for a client. And I think about 10 years ago, clients would wait around 30 seconds in some cases. Telnet was still in use, and web browsers were not necessarily up to speed, so they would wait a long time before returning an error to the client, or to the user, that is. However, after 30 seconds in a modern world, the client has gone away. They have given up. They have retried on the server. They have already displayed a message to the user saying they couldn't reach a site. And some clients wait as little as 4 seconds. And we've actually been working with several customers where we found out their CPE equipment waits 5 seconds and then moves on to another server, waits another 5 seconds, and then it returns error to the client, to the initial requester. So in bind 9.8, we've made this particular time adjustable. We still return serve fail just like a normal timeout. The difference is now that the client actually has a chance, the requester actually has a chance to get this serve fail. Where before it would appear as a timeout, now we answer authoritatively, we can't answer this question. And this is a big change because it allows somebody to move on to the next server and try it as well, as opposed to having to wait. We recommend setting this, if you do change it, somewhere within the 4 to 10 second range. I do encourage most people to change this, and I would set it to about 10 seconds. We did not change the default because this is a new feature, and unfortunately it's very network dependent. We'll probably will change the feature, the value in 9.9 to be something on the 10 to 15 mark, but we don't want to get too close. We don't want to increase the number of serve fails that are returned. Whenever we reach this timeout, we do stop working, and I say mostly here because we have cached everything up to that point. So if we continue with another query, we'll leave where we left off. We won't actually have to start back at the root and work our way back up again. So the first couple queries might get serve fail because very slow authoritative servers, but after that it should start working if the data is cached properly and doesn't time out during that time. You will see some additional serve fail responses. There are very slow authority servers. We've actually, in some of our analysis, we found some servers that will take up to 3 seconds to respond to a normal query. And of course you have slow network paths that are going to affect this. So you really want to monitor your servers before and after tuning this particular parameter so that you can measure if it's effective, if it's helping, or if it's hurting. You will see more serve fail responses, pretty much guaranteed. But you have to carefully consider, are those serve fails because now we're returning them more readily to the client so the client can retry a different query, which is also going to serve fail? Or are we returning more of them more quickly because there's an error and we're having trouble resolving that domain? So just a little bit of experimentation here and a little bit of trial and error might be necessary. So test this in your lab before you release it, of course. And this particular feature is kind of a strange one because it's in some ways it's a removal of a feature that we've added in the past. And this one is a little bit controversial because it involves security. RTP banding was added at one point in order to improve the resistance to certain types of cache poisoning attacks. And it would make these types of attacks from 2 to 4 times harder typically. The way it worked is if you had 2 name servers in your zone and they were both relatively close to each other in latency from your recursive server, you would use them both equally. That adds 2 times randomness or 2 times unpredictability, so it's much harder to poison. If you have 4 servers and they're all in the same range, you end up with the same one. You end up with 4 times that increase. However, the feedback we've gotten is that this actually affects latency sometimes very seriously. It also defeats the locality-based load balancing that many large content providers are attempting to do to try to provide the best possible service to customers. The way banding worked was, this is one of the cases that people were upset about, is that you typically have a DNS cluster very close to some consumer and then you also have one further away. In this case, for example, one might be on U.S. West Coast, one might be on U.S. East Coast, and the client, we'll say, is on the West. You end up talking to the servers local to you just as frequently as talking to something further away, as long as it falls within the same 128 millisecond band. Some questions we've had is, why didn't we just make the band smaller? Well, we could do that, but it's so sensitive to local configuration, local zone, or local network, and worse yet, the network link between you and some remote server that can change dynamically over time very, very fast sometimes. The band, no matter how small we made it, would end up effectively degrading back to our previous behavior, which was like this. This is what we do now in 9.8.0. This is what we did in 9.4 and earlier. We just use the closest server, and it's measured based upon the response times from those different authority servers. Now, these are not fixed in stone. What happens is, suppose we use that one with the green arrow. We will then improve all the other ones very slightly and move them a little bit closer to the left. Eventually, they will become better, and we'll try it and then put it back to where it was if the time has not changed. That way, we do learn of changes to behavior in terms of networking, behavior in terms of a server coming up or going down. We don't just lock onto the best server, and if it starts failing, stick with it. We will move on to the next server and mark that one very bad, and it will eventually improve whenever it comes back. So this is a snapshot in time at best. So the other question we get is, why didn't we make this an option? We just feel that the 2 to 4 times security increase is so minuscule that you can get that so much easier by simply adding 2 or 4 more ports to your configuration and allowing named to use 2 or 4 more UDP ports during that time. The other security mechanisms that we've added, such as port randomization, add 4,096 minimum randomness to this. So a 4,096 increase compared to a 2 to 4 times increase for this feature when it causes problems, it just seemed like a bad idea. Now, we didn't decide on that on ourselves. We heard from the content providers asking us to remove this. We heard from the resolver operators asking us to remove this. The arguments were the same, which is it defeats the speed up that they are wanting to provide to their customers. Whenever we hear both sides of the DNS space asking us to remove something, well, it kind of makes sense. Additionally, only one other server is doing this. Unbound does banding as well. I believe they use 400 millisecond bands. So we've been talking with them and saying, is this really a good idea? What features do you guys see? And they've also received a lot of feedback saying, wow, banding is a bad idea, so they're revisiting whether or not they want to continue providing that as well. So the change you should see if you are an authoritative server operator is that you might start seeing some changes over time on the query load on certain servers. But you're not going to see this immediately. 9.8.0, 9.8.1, 9.8.2, these are all, it's going to be gradually upgraded as people upgrade. You're not going to see a flag day where suddenly one server suddenly gets hit very hard. So just kind of keep your eye out a little bit more on these and see if there are some changes as people begin adopting 9.8. So the removal timeline is that 9.8.0, it's removed, cannot be re-enabled. 9.4 doesn't do banding. Now for our production releases that are more mature products, 9.6.4 will be the next version, 9.7.4 will be the next version, and we'll have an option to disable banding. But the default will still be to continue using it, so people aren't surprised. We're going to announce during that time very loudly that the next version will default to off, and we'll still keep the option to turn it on, but the default will become off. So this will give people time, if they really do want to lock it on, they can lock it on and not have to worry about it whenever they upgrade. There are some changes that we're going to be making in server selection. Banding did have one property that was nice, which is that it tended to balance out to multiple servers. So if one server goes down, very quickly you learn about it. But additionally, if 2 servers are very close together, you do want to load balance pretty fairly between those, and the current behavior tended to not do that as readily. So the Bind 10 people have actually been doing a bit of research into this, and they found some papers talking about a different selection mechanism that behaves much more like this, where servers that are very close to you as a resolver are weighted very heavy, and the further away you get, the less likely you are to use them, but it's probabilistic. So in this case, if you have a 10 millisecond and 20 millisecond, it's roughly 80% and 20% usage. The other ones are still tried periodically, but not very frequently. if you have two servers that are 10 milliseconds and 11 milliseconds away, you're going to use them roughly 50-50, which is a vast improvement over, it's back to the banding behavior in that regard, but it still provides the latency argument, which is it provides the best service available, probabilistically the best service available almost every time. And I wouldn't get very far without talking about some of the defects we've also repaired. Now, all of these defects have also been repaired in the other affected versions of ISC products, 9.7, 9.6, and 9.4. I list them here primarily because if somebody isn't running the latest version of some of our code, they might see some other changes that are beneficial. The first one on the list is performance. The address database scalability. This is a little bit internal, but internally Bind keeps an address database of all the servers it has spoken to in order to do recursive behavior. That was a fixed size, and whenever it exceeded that size, it would just become longer and harder to search. We made that much more dynamic, so you end up with a case where a very large resolver will scale out to a very large number of entries, so it becomes much quicker to look up things inside this database. So recursive performance has improved dramatically. We've also repaired another flaw with recursive performance, which is a reliability flaw, where the recursive client list would tend to explode with duplicate queries. This is where if you run RNDC recursing, look at the output file it generates, and you see a large number of clients that are all asking the same question, you really shouldn't see that. This fix fixes that problem. It was a logic error in our deduplication logic, and that's been fixed. So that's actually a major win for recursive servers. The next two here primarily are a focus of DNSSEC, and I don't believe these have actually been released in our 9.6 and 9.7 products yet, but they are going to be in the next version. Sometimes we didn't preserve the names case when we wrote things out to disk, and we didn't preserve the names case via NS update. That isn't really all that important until you start mixing DNSSEC in. So in some cases, unless you always use lowercase or always use uppercase, and some organizations use mixed case, where a common example is berkeley.edu, where edu is capitalized but Berkeley is lowercase. We now actually respect that, store it on disk properly so that signatures always validate when they're reloaded from our disk cache. And we've also fixed some race conditions inside of Bind with the auto sign and dynamic update race conditions, where if you did dynamic update, sometimes if it was in certain parts of auto signing, it would simply lock up the server. And with that, I believe I'm back to Larissa.
Thanks, Michael. So, here, sorry, hang on a sec. I have to reclaim my status as presenter here. Okay, so I want to give a very high-level overview of the roadmap for the rest of the year, and you guys are feel free to ask questions about this as we get to the question part of the presentation. So there's two more major releases of Bind 9 scheduled in 2011. One is Bind 9.9, and one of the main things we're going to do in 9.9 is DNSSEC ease of use improvements. It's some requests coming both from the community and from our own operations staff in DNSSEC. A feature that a lot of customers have asked us for over the years is the ability to do NX domain redirection, and we are going to implement that in Bind 9.9. We're also working on some performance improvements specifically around startup time and memory footprint. And then two caching-related things. One of them is serve fail caching, which is exactly what it sounds like. We're going to cache a serve fail so that the system doesn't have to keep looking for it. Obviously that expires fairly briskly. And then the whole answer caching, you could also call a DNS proxy. It's actually going to be something that sits in front of the DNS name server and acts as a proxy to cache whole answers. So we can get into more of that stuff during the questions if you guys want. We also have a release that will either be end of 2011 or the very beginning of 2012. That's Bind 9.10. It's a good thing we have Bind 10 coming because we're getting a long way with these Bind 9 release numbers. And the biggest feature in Bind 9.10 is what we're calling multi-master, which in this case it actually means that the last update wins. So it's a way of, you can have two masters, they can separate and then be healed, and the last update will win. And then internal health monitoring is we've had a lot of requests for more ability to monitor the internal health of your name server and be able to see problems as they're developing, and we're working on that. And there may actually be some incremental improvements in that area before the end of 2011, but this is when it's scheduled. The other thing that we're definitely doing for that release is some, well, we're calling it large server configuration settings. So this would be a pre-configured arrangement designed for servers with a lot of cores that would maximize their performance. So what I want to tell you is that most people will look at that list and say, that doesn't have the feature I want. Oh, well, there's two ways we can help you with that problem. One of them is customers of ours frequently sponsor features. So we actually want to get to a point where we have a list of features that we would really like to do, but we don't have the current resources to do on our website, so that you can actually sort of vote for them by saying, we're signing up to sponsor this, we want this one. For the moment, we've still got our traditional custom development model, where if you want a feature, you can propose to us and we will come up with a quote for you, and we will gladly work on it for you if we can. The more sustainable way of supporting Bind 9 development, which also gets you a voice in the roadmap, is to join the Bind Forum. Now, quite a few of the people on the phone today are already Bind Forum members, and I want to thank all of you very much for your support. Quite a few of you I know and really value your partnership over the years. There are also lots of folks here who are not Bind Forum members, and I want to say to you that our client services manager, Sue Graves, gave me permission to offer 25% off first-year new forum members who are in this session. So if you're interested in that, there's information on our website, and you can go there, and if you actually want to become a forum member, when you go to sign up, just indicate that you were in this session and you will get that deal. Some of the benefits of being a forum member include roadmap planning input, and you can give us input anytime, but also we offer periodic webinars like this one, but more participatory. We would do ongoing polling, and people could basically vote for the direction they'd like to see roadmaps go. We also do surveys of our forum members, and then we also have a face-to-face forum meeting once a year at the summer IETF session. Our forum members also get notification of Bind security issues in advance when that's possible. If we get a zero-day exploit, of course, that doesn't happen. But otherwise, you get notification in advance, and that is very helpful to people who have large installations or to integrators. So folks who have operating systems or appliances with Bind inside find forum status as an OEM level participant very helpful. We offer integration support for your application and making sure that Bind works well with it. And of course, not that this is the topic of this session, but we have the same forum model for all of our software, for DHCP and after as well. So just moving through quickly, a couple more things that folks should know about in terms of supporting your DNS infrastructure. ISC offers customer support on Bind and our other software. That's professional level 24/7 technical support from the Bind experts, that's us. Our support engineers have access to the developers of Bind, and that's a level of support that is pretty hard to find in many organizations. We also offer a training program that covers Bind, DNSSEC topics, DHCP, IPv6 topics, and there are some SIE workshops now as well. It's a lecture and lab combination, and I've attended many of the trainings, and I think they're outstanding personally. And as I mentioned earlier, we have a consulting program that can help you with deployment, audits, ongoing issues, performance issues, getting through any sort of upgrade requirements, best common practices. There's a lot of ways we can help you with your DNS there, and we'd love to talk to you about it. So just really quickly, just so you can see there's a lot of Bind trainings coming up. Where it says that it's a 5-day introductory and advanced course, you can actually take either introductory, advanced, or both. So you have a combined option there, or you can take them separately. And then there's the DNSSEC implementation and deployment workshop available as a standalone, but in the advanced bind topics, that also covers DNSSEC. And I noticed that the URL is cut off on the bottom of the page here, but it's www.isc.org/services/training. Last but not least, I want to tell you that we've got more web seminars coming up. We've really been stepping up our web presence, and as Barry mentioned at the beginning of this call, we're going to be having sessions for major software releases like this to let you know what's coming out, and then also to make the slides that we have available. All of our slides will be available in PDF form on our website at the URL that's at the bottom of this page, and you are welcome to share those with appropriate credit with your colleagues, your management, whoever you need to talk to about why, for instance, like to upgrade. So just really quickly, upcoming web seminars. We had a very successful IPv6 overview seminar a couple weeks ago, and we're following that up with 2 sessions. The first is March 23rd, IPv6 for carriers and ISPs. I don't know how many of those folks are in this call, but we've had a lot of questions around how carriers and ISPs should use transition technologies, and then what that means for them in terms of things like their legal obligations regarding lawful intercept, because it gets a little trickier than it is with regular v4 or with straight dual stack. So we would like to get into some more of those matters there. The Security Information Exchange folks are going to talk about Security Information Exchange and Passive DNS on March 29th. So if you are someone who already collaborates on security information or would like to, this is probably a really good session for you. We have a few sessions, I mentioned this feature a little while ago, that are specifically for our forum members, and there's 2 of those in April. They're both feature and roadmap planning, one for DHCP and one for bind. And then the second of our follow-on IPv6 sessions is going to focus more on stuff that enterprises would need, large corporate networks, and we'll get into issues like how you deal with v4-only legacy applications or v4 isolated user endpoints that are v4 only, or clusters of phones you can't upgrade that are v4 only. There's various things. So, and then the last session that we have currently scheduled is another forum-only thing. This is a 3-part series that we're doing for our forum members that's quite technical, getting into key management best practices, and this is following on one that we did last fall. So just like with this session, there's 2 per day, trying to make sure we're available to the whole round planet. And there's the URL, isc.org/webinars. Okay, we have gotten to the questions part of the day. I am going to unmute my colleagues, and then I will call out the questions that I've already seen, and we'll take it from there. I'm unmuting you, Michael, and I'm unmuting you, Barry. And I saw some questions while I was talking, so I'm, oh, well, this one I can answer really easily. The URL to join the bind forum. If you go to, I apologize, I have the URLs on these slides and they seem to have dropped off the bottom. If you go to isc.org and then you go to software, you'll see the forums on the right-hand side. You can click on that, and that will give you the form you need to join bind forum. The other questions that I saw, okay. We had one on, is there any monitoring of timeouts currently or planned so that you can analyze the timeouts that are occurring? And Michael, I see you answered that online, but could you address that in the call?
Yep. We are pretty aware that we don't always report back error messages and situations very well. Sometimes I think we report too much information that in many cases a local resolver operator can't fix, but we still report it. In other cases, we don't report some of the things that people really do need to be able to diagnose certain problems. In this particular case of why timeouts are occurring, it's almost always one situation, which is we cannot resolve some step along the way. What that step is, of course, changes, but we'll probably resolve that by having a counter someplace that you can query to find out why a name's failing, as opposed to actually logging that to syslog or something, because in many cases, logging to syslog is sort of a general fix that doesn't really help all that much in the general case unless you're actively trying to debug something. So this will also be something that we're going to address over time. As we find our deficiencies in this, please let us know if you see something like, wow, it would be really useful if you could find out this thing. That's feedback we want to know, because that's something we can fix, and that's something that if it makes your life easier, we would like to fix. And it's not going to be all at once. It's not going to be done at one particular moment. It's on the roadmap for 9.9 and 9.10, but it's a progressive transition to get there. It's not going to be a one-stop, all of a sudden now we're better at it. It's going to be an improvement over time.
Thanks, Michael. Okay, I have two clarifications from Sue Graves, our Client Services Manager. She's sending me messages here. And then we have one more question that I see, and if people have more, I'd love to hear them. So the two clarifications are, one is that while you can take the introductory DNS course as a standalone, you can't actually take the advanced course as a standalone. However, we do have the 3-day DNSSEC workshop, which you can take as a standalone. So if you have questions around that, you can contact Sue through the website. And the other thing is just to make sure that people know that the 25% off discount is for supporter and up levels. It's not actually for the individual membership. So the other question, which I am pulling up here right now, was about DNS 6.4. And I know that DNS 6.4 is not Michael's area of expertise, so we can always get back to this person on the question later, Michael, if you don't know, but here's the question. One of the DNS 6.4 slides said that the client would get both A and quad A records in the reply, but wouldn't the client have specified QType equals quad A in the query and thus ignore A RRs in the reply?
The answer is yes, and I do not know the correct full format of that. I did not implement this, and I'm not a DNS 6.4 expert, as Larissa mentioned, but if you send mail, we can get back to you on that one.
Yeah, we'll do that. Okay, are there any other questions? Oh, here, sorry, I see one. Hang on. No, that's not actually a question. It's just Michael saying he answered a question. Sorry. Okay, here's one more. Related to the RTT banding issue, is there a way to have bind dump statistical information regarding which servers are preferred for querying a particular zone, including the root servers?
The answer there is yes. It's not a cheap operation right now. You can do a RNDC dump DB-all, and it will dump everything that bind knows about everything in its cache, as well as the ADB and all that sort of information. You can also dump, I believe, just the ADB in some versions. Unfortunately, this is not a one particular set of servers, and it's not a query into the existing state. And of course, as soon as you query it, it's probably going to change. But in a snapshot in time, you can get that information. It's also not direct. It doesn't have a flag that says, I'm using this one. It simply says what the RTT value, measured RTT value is, and you have to visually glance to see what the lowest number is.
Okay. So that's the whole answer. I'm sorry, I didn't mean to cut you off.
That's the whole answer.
Okay. So we have another question, which I can answer. Do you know if all of these new features are communicated to all companies that handle DNS product solutions, such as F5, Infoblox, BlueCat, et cetera? And the answer is this. We make our webinar schedule as available as we can. It's on our website, it's on our Facebook, it's on our Twitter, it's on our LinkedIn, and we want this information to be completely publicly available. We're trying to be as open as we can be about our roadmaps. That said, if folks aren't members of our forum, and I'll say some of those people might be, some might not, that we don't necessarily push to them if we don't know who they are. I'd also like to say, though, that I'm working on developing closer ties with all vendors who include bind in their products, and that if anyone who's out there in this call wants to develop a closer relationship between our product and yours, I would encourage you to contact me. My email, my personal email is larissas@isc.org, and I'll make sure that that's in the follow-on email that goes out after this call. Thank you for that. Okay, here's another one. Bind 9.8's ADB hash fix. You mentioned performance improvements for recursive servers. Michael, do you have any feeling on how much of a difference it will make in real-world performance?
It is actually, of course, very situational. But if you have a really large cache and you speak to a lot of servers as a large recursive operator, and whenever I say large there, I really mean serving 1,000 clients, 500 clients even. It can be as small as that. What we did is we had 1,008 buckets for the address database, which means if you've spoken to around 1,008 servers as a recursor, it didn't have to do very much work. We found that the customer we fixed this for primarily, they had around 500,000 entries in the address database. And that means on average we had to look at 5,000 entries on each of these buckets. So it was a pretty big loss there, and it's a linear search at that point. Once it gets the bucket, it's a linear search to walk through there to find the answer. It also holds the lock during that time, preventing other lookups into the database from occurring. So not only is it just a CPU time increase, it blocks other queries for a short while it's doing that search. Whenever we scaled this out, we found that the locking contention and the average rate increased by about 15 to 20% for this particular customer. So it's a pretty big increase if you really do have a large address database.
Okay, so one more question from one of our previous questioners. Correct me if I'm wrong, please, but I think banding also works best when you have more than, I think he means more than one server to forward statements. I do not understand clearly why this function will be removed in new versions.
Okay, I don't actually see that question in text, but...
sorry, I don't know. Maybe it only came to me. I'm not sure.
Okay, well, I'll attempt to
answer. It's in Q&A panel.
The banding does work primarily whenever you have servers within the same band, but because the band was so large and it's so hard to tune that to be a proper parameter, we really want to fix the problem that banding applied, which is the balancing configuration, separately from the security aspect. The security aspect is pretty much a wash. A 2 to 4 times increase is just not worth it. Going back to the previous behavior, we felt was safe because that was the previous behavior. And at the time, it seems to work fine now. So it's not the end of that path. We want to get back to the behavior where it tends to prefer closer servers, but will use multiple closer servers very fairly. So we want to fix kind of the latency, load balancing distribution mechanism separately from the security aspect that banding had. Banding was clearly not the right answer because it was the worst case for every situation we could find.
Thank you very much, Michael. Okay, I do not see any more questions right now, and it is 9 o'clock here in California. I'm going to say, oh wait, maybe one more, hang on. No, it's just people saying thank you. So, going once, going twice on the questions, sold. I want to say thank you so much for attending. You're the reason we do this.
And
you can visit isc.org.
If there are other follow-up questions, feel free to send mail to us, and we'll be happy to respond to them.
Absolutely. And you'll be getting an email from us later today with some follow-on information, which will also include a link to the slides and the WebEx archive. So thanks a lot, everybody. Bye-bye.